Okay, so in this video, we're going to look at a concept called an inverse trigonometric ratio or inverse trigonometry ratios. All right, so let's see what problem we need to use inverse trig ratios for. Let's say we start off with this right triangle here. So this is angle QRS, this is 12, and this is 8. And you are asked to find the measure of angle Q. Okay, so we have two sides of a triangle and we want to know what is this angle here. What is the measure of that angle? All right, well, let's go ahead and set up a trig ratio. So let's see here. Relative to angle Q, we have the adjacent and the hypotenuse, so that would be cosine. So the cosine of Q is the adjacent 8 to the hypotenuse, over the hypotenuse, 12. Okay. All right, well, we have this ratio of sides, but how do we get that angle? So let's look at this on a table. Let's get an approximation for this. The cosine of Q, first, is what? Let me turn on the calculator. 8 divided by 12 gives us 0.66667. All right, so we know the ratio is 0.6667, so let's go to our table here and look for about where is 0.6667. And as I'm going along, I notice around here between, it appears 48 and 49 degrees. So, you know, this is from table. Okay, so at 48 degrees, it's 0.6691, and 49 degrees, we end up with 0.6561. So 0.6667 is somewhere in between 48 and 49 degrees. And, you know, honestly, that's actually a pretty good guess. However, what if we want to be a little more accurate? What if we want to know the actual angle, you know, accurate to a certain number of decimal places? Now, of course, you could probably try to do some interpolation between these two, where you figure out, well, how far is it from these two, and then figure out the angle between that. And that actually probably wouldn't be a bad guess. However, just like with when we had to figure out like the sine of 36.8 degrees, we were able to use a calculator instead of doing some interpolation. We can do the same when it comes to finding the angle. But one thing I want you guys to understand is that when we do this next thing with these inverse trigonometry ratios, what we're doing is we're going from the ratio to the angle. So beforehand, we were always going from the angle to the ratio, and this time we're going to go backwards. Okay, so this is inverse trig ratios. Okay. All right, and the inverse trig ratios, there's two ways to say them. We either put the cosine to the -1, or we would put this a cosine. Okay. Now this means inverse cosine. This means arc cosine. They do the exact same thing. So now, of course, depending on your calculator, when we go to this calculator here, you're going to notice right above the cosine is cosine to the -1. So that actually means inverse cosine. Some calculators might have this a cosine. If it does, then it's the same thing. We'll talk a little bit later on in the course about what these actually mean. But for right now, it's good enough to just kind of think of it as, you know, instead of having an angle and going to the ratio, we have a ratio and we want to go to the angle. Okay. Now, the sine and the tangent have the same thing. We have the inverse sine or arc sine, and then we have the inverse tangent or arc tangent. So inverse sine inverse tangent. Okay. And it's one of those things that these are used interchangeably. You'll have some situations where you see the inverse a lot. Actually, when you start getting into more upper level courses, you start seeing the arc version. So we'll try to use them interchangeably so that you just get used to it and you can recognize them both. Okay, so let's see how we use this. Back up here we had the cosine of Q is 8 over 12. So the cosine of angle Q is 8 over 12. Okay, so even though we haven't technically defined these yet, we'll do that later in the class. One thing we can say is if you have this set up here, cosine of Q equals 8 over 12, you can automatically go back and forth between this and the measure of angle Q equals the inverse cosine of 8 over 12. So by definition, we can go back and forth. So if you have this, you can come here. If you actually had this, you could come back over here. All right, so let's go ahead and put that into our calculator. So what we're going to do is, now because it's in the, now remember, you got to make sure you're in degrees, not radians. And what we do is you hit the second cosine, if you have this TI calculator, and it's 8 divided by 12. And we end up with 48.19. So the measure of angle Q is 48.19 degrees. And there would be the answer. Okay. And now it's pretty, we set up here, it was going to be between 48 and 49, so it ended up being between 48 and 49. So that's good. All right, so let's go ahead and write this down. I've said this a couple times, but you do have to remember this, that if you want to go from the angle to the ratio, that's a trig function. If you want to go from so here's angle and here's the ratio. If you want to go backwards, that's the inverse trig function. Okay, so you kind of have to remember which way you're going. Are you going from the angle to the ratio or the ratio to the angle? And that'll help you determine which of those two buttons you need to use. Okay, let's do a couple of examples. Let's say we have this triangle here. This is going to be E, F, G. That'll be our right angle. This will be 100, and this will be 37. And we want to find the measure of angle F. Okay, find the measure of angle F. So here's the angle of interest, angle F. And relative to F, we have, let's see, that's the opposite side, that's the hypotenuse, so that would be the sine. So the sine of angle F, actually you don't have to put in the angle, so let's rewrite that. The sine of F equals the opposite over the hypotenuse. Okay, so there's our setup. Now, just like we were able to go back and forth here, once you have this ratio, you can automatically go to the inverse. So we can say the measure of angle F is the inverse sine of 37 over 100. And then we take out our calculator, and the measure of angle F is going to equal, let's see here, the inverse sine of 37 divided by 100 is 21.72 degrees. And there's our answer. Good. Okay, let's go ahead and do one more example. And this example is not hard. I just want to make sure everybody understands what this means. A road has a 5% grade. What is the angle of elevation? So if you've ever driven in the mountains, which a lot of people have, you'll notice on the side of the road there'll be some kind of grade. They'll say caution, 5% grade next couple miles, 7% grade, whatever it is. And so what does that mean? So what is a 5% grade? And essentially what a 5% grade is this. So you have to imagine there's our car, it's going up, and here's angle A. And what it means that for every 100 feet you go horizontally, you go up 5 feet. So the angle of elevation is this one here. Remember, you go up to for angle of elevation. And so now we can get that angle. So let's see, that's opposite, adjacent, so that's the tangent of A is 5/100. We can automatically go to the inverse. So the measure of angle A is the inverse tangent of 5/100. And so the measure of angle A is equal to, let's see what that ends up being. The inverse tangent of 5 divided by 100 is 2.86 degrees. And there is our answer. Okay, so there you go. New concept here, the inverse trig ratios. So you have to recognize when it is an inverse. So it can be shown two ways. You can have that -1 up there. So that means inverse sine, inverse cosine, inverse tangent. Or it can have a little a in front of it, which means arc. So arc sine, arc cosine, arc tangent, and so forth. And remember, when you're using an inverse trig ratio or inverse trig function, you're going from the ratio to the angle. So you're going backwards on that table.